Good afternoon. In today's webinar, you can hear about VNF scaling using Nokia VNFM. This webinar was meant for ETSI SpecFest and was demonstrated in Denver, Colorado in September 2017. Let me introduce myself. My name is Hunor Demeter, and I am working as product owner in Nokia CloudBand Application Manager, which is Nokia's VNF Manager. Should you have any question regarding this webinar, you can reach me in this email address. Let's jump to the agenda. Today you will hear about Nokia VNF Manager. Then we look about Nokia VNFM API capabilities, and I will spend most of my time about hands-on exercise with VNF scaling. And I will conclude my presentation in section 4. The presentation will take approximately 30 minutes. With that, let's start with the first part, Nokia VNF Manager. What is the role of a VNF Manager? Most of you probably know it manages the lifecycle of one or more VNFs on cloud instances. How that is done? First, we create a VNF from a package, and after that we instantiate that a VNF on top of a cloud instance. After that, based on the VNF capabilities and traffic demand, we can scale out or in. In case of any problem, we can heal it. And finally, when it's not needed, we can terminate it from cloud and delete from the VNF Manager. This lifecycle can be repeated as many times as needed with one or more VNFs. Okay, so this is relatively simple interface, but let's look a bit under the hood. So how that is implemented in a VNF Manager. As you can see, a VNF Manager from this perspective has multiple interfaces to interact with. One is the orchestrator interface, specified by ETSI NFV SOL 3, and the other is the element manager interface, which is defined in ETSI NFV SOL 2. Both of these interfaces can execute, for example, scaling operation. And in order to fulfill it, the VNF Manager contacts to the Vim interface, the cloud interface. In Nokia case, this can be either OpenStack or VMware vCloud. And another interface, the VNF commissioning interface, to communicate with the resources of a VNF in order to commission and bring it up. Let's take an example, the scaling. What do you think? How many lines of code requires to call scaling on VNFM API? You will see it later on today's webinar. It's 4 lines of code, so it's very simple. You define an aspect, you define the needed step, out or in, and you can fire it. And what do you think? How many lines of code implement scaling for our relatively simple demo? Again, I can answer it. It's approximately 2,000 lines of code for scaling, which is a long-running workflow. First, it identifies the heat stack to be scaled out. After that, networks are connected with new virtual resources, and the virtual resources are brought up in terms of operating system and functionality. And all of that you can do with 4 lines of code in the scaling operation. If you are interested about our Nokia VNFM, you can find us here in this link. And let's jump to the second section, which is Nokia VNFM API capabilities. Currently, these are the interfaces and operations implemented by CBAM. In top of what we already discussed, there is possibility to query the VNF state anytime or an operation state anytime. and also we can modify certain VNF information elements as defined by ETSI. We have also implemented the VNF Lifecycle change notification interface, which is a very interesting interface. One can subscribe to certain events, for example, scaling, and when the VNF manager starts or ends an operation, it will notify the subscribers about the changes. On top of that, we have additional operations which we would like to be standardized, but we already have implemented. So this is the VNF upgrade operation, which is very important during the VNF lifecycle. And the other one is modify Vim information to change, for example, username password from time to time towards a Vim. And fortunately, this already have reached ETSI SOL 002 and 3, and it's part of modify VNF information. We also have a package management interface to query, upload, download, and onboard artifacts. And let's jump to the third section, which is the hands-on demonstration, how to scale a VNF. Let's do first a recap. So here you see the well-known ETSI SOL 003 scaling aspects. An aspect can be scaled by steps, and all the time it can be scaled from 0 to maximum level. In this example, we have a service aspect, which is scaling from 0 to 2, and the DB backend aspect, which is scaling from 0 to 4. Each step can have a certain amount of virtual resources. As you will see in the demo, the service aspect will scale in one step with 2 virtual machines, while the DB backend scales with 1 virtual machine in one step. There are also certain selected elements which we call instantiation levels, and that also helps the user to instantiate a VNF on a certain instantiation level. For example, the yellow one is a small VNF, while the blue one is a large VNF. Okay, so let's see what is our demo application building blocks. We have here 2 types of node, the service node and the database backend node. The service node is the one who accepts SQL queries from external clients and stateless, while the database backend is a stateful service and stores application data, response to service node queries. Okay, you can ask that, how could we scale this application? Okay, the answer here is that you cannot scale this application. It has a service node and a backend node. That's all. So let's make it scalable. Let's create a VNF. First of all, we have to create a reliable solution. So we have chosen to create a database backend with multiple nodes in a cluster. So to synchronize the data, and in case we lose one node, the other 2 nodes still have the state and can respond to queries. We need a database synchronization network between these backend nodes, which should be a fast network. Also, we need service nodes which communicate with the external nodes and DB backend nodes, and we need an internal network connecting the nodes together. What we need? More, it's an access network where our nice VNF can be reached from outside. As you have seen, we have chosen that the service nodes are in pairs, so in case one service node is lost, we still have another service node serving the request. Okay, so let's talk about scaling. So first of all, we define certain so-called static nodes, which are outside of any scaling aspect. These static nodes will be always part of the VNF. You cannot scale them down to 0, and this is because we would like always to have a state of these 3 nodes, defined by these 3 nodes. Let's define right now the aspects. First, a service node aspect, which is scaling from 0 to n. And as I told you before, we have chosen to have in one step 2 service nodes. And we can scale it out with an additional step as shown in this picture. Let's also define the database backend aspect, which can scale from 0 to n, but it all the time adds on top of the static nodes. So the first step, it creates another virtual machine. The second step, yet another virtual machine. Okay, so one important question: what happens if I scale down, for example, the service node aspect to 0? So what happens is that we lose all our service nodes. Is that a wise choice? It depends. For example, there can be cases when you would like to do maintenance, and definitely you don't want that your database nodes are affected. Or there can be certain external attack, and you would like to protect your variable data, and then you are scaling in your service to 0 in order not to be reached from external world. Okay, so let's move on. How our demo application will look like. So we will have an instantiation level small with 2 aspect nodes and 3 backend nodes. These are the static nodes. And on top of this, we can define the scaling steps both for service nodes and for the backend nodes. And we will choose a case when we will scale out the backend nodes to additional 2 VMs. I would like just to highlight that there are also other considerations when you are creating your VNF. For example, you have to think about anti-affinity, which means, for example, in our case, that the service node should be in anti-affinity setting. If there is a physical node where the service node is bind to, it can never happen that 2 service nodes are in the same physical node. So if you lose one physical node in the cloud, still we will have one surviving service node. For the backend node, we have a stronger anti-affinity setting. All of the backend nodes should be in anti-affinity group. In this case, the 5 backend nodes should be in 5 different physical blades. Okay, so let's see our OpenAPI schema. So how the scaling looks like. First of all, we have a path for scaling. This is how you are scaling a VNF. So you invoke the scale path, and this is the dynamic part, which is the VNF instance ID. You do a post operation. The method is post, and there are certain parameters. One of them is the reference VNF instance ID, which is coming from the URI, and the other one is coming from the body, and it's required. This is the scale VNF request, which we will see later in this demo. And here you can see also a defined response, which is a normal asynchronous response to O2 when the operation is accepted. This naturally means that the operation is started, and it will run for not defined time. We will see that also later. This is our current implementation, which came out actually before Sol 003, and this is our planned scale operation. The only difference, as you can see, is that the VNF instance is path instead of abbreviated VNFs path here. So this is what we are planning to be fully So 003 compatible. As you can see, the other things like the response codes, input parameters, and method is the same. Okay, so this is our demo environment today. We have a controller node and 6 hosts in an OpenStack cloud, which is Red Hat OpenStack Mitaka. And we organized our resources such way that we have 2 availability zones, compute A with 4 nodes and a compute B with 2 nodes. I can also show it the Horizon dashboard for you. This is how it looks like. I have to Go back. Authenticated. You can see that currently we have 16 instances in this cloud. I can tell you that we have here 2 CBAM instances, one for demo and one backup for the demo, and both both CBAMs manage VNF, and the VNF currently is on small level, so it has 2 service nodes and 3 backend nodes each. Okay. Going back to the presentation, let's do our first ever scaling operation. Okay, so let's do first a pre-check. Let's see that we have a VNF query operation which returns our VNF ID, and I will show you that we have those VMs in OpenStack Horizon. So our naming convention is so that we prefix each virtual machine name with the VNF instance ID, as shown here. For example, the backend nodes are VNF ID dash backend. Okay, so let's then have a look on that. I am using Postman for demonstration purposes, and I have already issued VNF info and scroll down for you to the appropriate part because it's a relatively large information set coming back from VNF information. And what you can see here that the scaling status is currently 0 for the DB backend nodes, and the level is 1 for the service nodes. Okay, what it means is that we have in this level 1, 2 service nodes and 0 DBS backend nodes in the scaling aspect. Of course, we have the 3 static nodes, altogether 5 nodes. Okay, so let's then go up to the top of this VNF information set. You can see that we had an operation which is already finished, and right now you can see that we have here certain nodes. We have a static backend node 2, static backend 1, static backend 0, and we also have 2 service nodes here, in total 5. So we fortunately found the 5 nodes on Horizon. This is our initial state here. Let's then go back to the scaling. Okay, so what we will do, we will issue a scale request on the DB backend aspect, and we will execute 2 steps. This is because when you are clustering database, it's all the time wise to have odd number of nodes. And what is the expected outcome? The expected outcome is that this is accepted, and since this takes 7 minutes to complete, we will only check that we have an operation occurrence link in the header and revisit the operation after it's finished. Okay, so let's do that. Let's go for scaling. Here you can see that I will issue in the body the following scale info. We will scale out the DB backend aspect with 2 steps. Okay, you can disregard the part down, that was a previous one. Okay, so let's do that, and what you can see here that the status is 202 accepted, and if you are just looking to the headers, we can also see that here we have an operation occurrence ID that we can poll and see the progress of this operation. You can see that there are additional links here when it started, what is the ID of this operation, and so on. Because it takes time, I would propose that we are just going forward with some additional scenarios, and we'll visit this scenario later. Okay, so the second scenario would be to scale out on the same time when there is a scale out operation ongoing. And the expected outcome is that this will result in a 409 conflict. Why this is important? When there is an operation ongoing on a VNF, this is potentially can result in conflict if we allow multiple operations to happen in the same time. For example, a very easy thing to understand is that instantiating and terminating the VNF in the same time would not make any sense. Now we are just scaling out the VNF while it's scaling out, so just to see that this is happening. So we have the same operation. I try to put it one more time, but as you can see, I have a 409 conflict, and it refers back to the running operation execution why this operation cannot be executed on this VNF. Of course, you can execute a scale operation on another VNF in the same time. Okay, so let's then go to another scenario, the scenario number C. So let's right now do a bit of tricks here and make a request without a valid OAuth2 bearer. In this case, our authorization servers should reply with the 409 unauthorized, and I will do it this via the following method. I am just showing you that we have a bearer token here, and what I do, I just add some bad token word on the end of the token, which will render our token invalid, and execute the operation once more time. So as you can see, we are not authorized because we don't have a good token. So basically, this scenario is also running smoothly. Okay, going back, let's see another scenario. Let's right now have an invalid URI path. So let's create an invalid VNF instance ID. And again, we should get a for not found response because this resource may be not available on VNF Manager. So how to do that? Again, I am playing with the scaling. Let's put here like bad VNF ID, so we don't have this VNF ID, and send it in. Of course, I modify the token to be usable. Still, I get an unauthorized because probably my token expired, so I go and get a new token here and go back to the scaling with the bad resource URI. And what you can see that the response is for not found, and there is also a detailed information that this VNF ID doesn't exist. Okay, so I am just modifying it back. Okay, so let's check the status of our current scale operation. You can see here that the scale operation is still ongoing because it takes, as I told you, several minutes to complete. And what I would propose here still to try yet another scenario in the meanwhile, which is the out of the bound case for the scaling. So you have seen that the max scale level for the DB backend aspect was 8. However, right now I will order CBAM to scale out with 100 steps, which is definitely well above the limits. And I am expecting back a 42 unprocessable entity response. Of course, since the operation is ongoing, I cannot execute this one on the same VNF because I will get a 409 conflict. So what I do, I have a spare instance here of the CBAM and a spare instance of VNF. And I just acquire a token here. And let's do this case on the second instance. So here, as you can see, I already set the scale out to 100 of steps. And I have already run it, but let's run it one more time. And not surprisingly, we get the error message 422 unprocessable entity, and the detail is saying that the scale level is not valid, so the acceptable level is 8, current level is 0, which also shows that our VNF has not yet scaled out totally. Okay, so let's then jump a bit to another part of the demonstration. Right now I would like to show you another view of our REST API, which is the CBAM graphical user interface. This is built on the top of the REST APIs, but it's a more user-friendly way to present the information. Here you can see that the scaling has started, but is still running. We have only one VNF here. And if we are just jumping to the details, we can see the onboarded VNF package information and the VNF provider, product name, and even we can see that what operations are allowed on this VNF. You can also see that there are certain other operations which are defined. However, because only one operation can run at one time, only the scale is not grayed out. We can also see that what happened with this VNF. We can see that it was instantiated, and we can also see that we started to scale it at this time point. We can also see additional information here, which is the instantiated VNF info. I would like just to demonstrate for you that it's exactly the same JSON that you have seen on the REST API. So I download the full JSON and open it with the text editor. And I show you that the scale status, which we were just covering on the beginning, is here. And you can see that the target level will be set to 2. So we are waiting to that to happen. And going back to the REST API, I would like to poll one more time our VNF to see that where we stand now. Okay, so we go back to the first environment where we executed the scaling with 2 steps. And right now I am just polling the information set. We still see here that the scaling is started. And of course I can go only for this operation execution. And of course my token just expired, so I take another token and try to do it, and I get back the same information over here. So we have to wait until the scaling is finalized here. So until that is done, let's go to the horizon. And check the number of instances here. Okay, so it's interesting. We have already 7 instances here, which means that the 2 additional virtual machines should have been added. So yeah, you can see that there are the 2 service nodes, no surprise of that. We have the static nodes here, and additionally we have 2 backend nodes, which are not part of the static part. This is the backend 0 and backend 1. So one can ask that why the scaling has not finalized, since we have these nice virtual machines here already. So is this a bug? And the answer is not, because this is only part of the long-running workflow to create the virtual resources. And the workflow is only finalized when we also have the virtual resources commissioned and configured correctly. But as you can see, at this point, we have the scale success, and we have another operation finished on the UI. And if we go back to the Postman and check the status, which is currently was status. You can see that it was finalized. Okay, so with that, we demonstrated that scaling works, and this was the end of section 3 of my webinar. And let's go for the conclusions. So the conclusion is that ETSI, NFV, Alpha 7, 8, and 11 provide solid basis for the information model. As you have seen, we have demonstrated in the VNF query. And also ETSI, NFV, SOAR 2 and 3 are great achievements and provide the required data models and protocol descriptions for that. And most important of all, it already works. That's great. There is also another initiative which we think that ETSI NFV made the right decision, which is about Open API initiative, which is coming in the near future, and it will provide useful interoperability between components and vendors for the future. With that, I would like to thank you for your attention and see you another time. Bye-bye.